Welcome back, Cubs. This video, we're going to be going over limiting reactants. Um, so let's get into it. So limiting and excess reactants. Anytime you have a chemical reaction with at least two reactants, one of those will be limiting and one of them will be in excess usually. So that means the limiting reactant, this is the reactant that gets used up first. If you run out of one of the reactants, then the reaction stops because you have no more starting material to work with. Then the excess reactant, that's going to be the substance that's not completely used up during the reaction, so you'll have some left over. And we can calculate the limiting and excess reactant by following these steps. So when you read your problem, anytime you have two reactant values given, you know that it's going to be a limiting reactant problem. So you first want to identify the limiting reactant by determining how many moles of a particular product could be produced, and then whichever value is smaller, that's going to be your limiting reactant. So the reactant that has a smaller value from step 2, that's going to be your limiting reactant. Then you can use this given amount of the limiting reactant to determine how much of each product will be used and how much excess will remain. So we have this example here. We have 0.855 grams of chlorine and 3.21 grams of potassium bromide. So we know that this is going to be a limiting reactant problem because there are two values given for reactants. So we want to know which one is the limiting reactant. So we need to have our balanced chemical equation. Chlorine is going to be reacting with potassium bromide to give us potassium chloride and bromine. Remember, bromine's diatomic. So we have two values given here. We now need to convert these two values to moles of chlorine, then to moles of one of the products. It doesn't matter which product you choose initially here, as long as it is going to be the same product that we use in the second equation here. So we're going to do the same thing. Instead of starting with chlorine, we're going to use potassium bromide. And then for moles of potassium bromide, we can go to moles of the same product here because we want to do a comparison. We're going to get moles of KCl in both of these cases. So we're going to be assuming that if 100% of this chlorine gas reacts, what's the maximum amount of potassium chloride that could be produced? Then we'll do the same thing. If we have this amount of potassium bromide, what's the maximum amount of potassium chloride that could be produced? So we'll get two values for potassium chloride here, and whichever value is smaller, that's going to indicate our limiting reactant. So we go in and fill in our values here. For grams of chlorine, we'll use the periodic table and add up the parts. Then mole over mole, refer to the balanced chemical equation, use the coefficients. So the coefficient for chlorine is a 1. The coefficient for potassium chloride is a 2. So we have 0.855 times 70, divided by because it's in the denominator, divided by 70.90 times 2. And that will give us 0.0241. So if we react all of this chlorine, this is the maximum amount of product that we could get if this was in excess. But let's find out how much we can make of the potassium bromide. So gram and mole together, mole gets the 1. Then for grams of KBr, we need to add up the parts. Potassium is 39.10 plus bromine 79.90. So we get 119 here for the molar mass. of potassium bromide. Mole over mole, use the coefficients from the balanced chemical equation. So then we calculate our value. We have 3.21 divided by 119. Hit enter. We end up with 0.0270 with our 3 sig figs there. So which value is smaller? Well, this value is smaller. So this indicates that chlorine would be our limiting reactant. Make sure you're identifying the reactant that is limiting. KCl, if we box this, that would be incorrect because KCl is a product, not a reactant. Now for the second part of the question, it says how many grams of bromine are produced? Right here, how many grams of bromine are produced? So we take our limiting reactant. So we use our limiting reactant because once this is used up, the reaction stops. So this was A. To answer B, we take 0.855 grams of Cl2. Now the question said how many grams of bromine could be produced. So our unknown is grams of bromine. So our given is in grams, our unknown is in grams, so we're going to do a mass to mass stoichiometric calculation. So we start with 0.855 grams of Cl2. Remember, this unit is going to drop down to the denominator. Allows us to go to moles of Cl2. Then from moles of Cl2, we can go to moles of Br2. So this step here is important. Remember, the unit substance can only change when we have mole over mole for a stoichiometric calculation. This unit drops down. We have moles of Br2 and then grams of Br2. Okay, so we'll see that our units will cancel out. So let's fill in some values here. Mole, grams, we get the grams by adding up the parts from the periodic table. Mole over mole, use the coefficients from the balanced chemical equation here. Then gram and mole together, mole will get the 1. Then for grams, we add up the parts. We have 79.90 times 2 for bromine. Gives us a value of 159.80. So double check, make sure that those units cancel out. And they do. So now let's use our calculator. 0.855 divided by 70.90. Hit enter, times 159.80. Hit enter. So a total of 1.93 grams of bromine will be produced. Then we have step C. How much excess reactant remains? So to find out how much excess reactant remains, we're going to want to take a look at page 297. So after reviewing page 297, we can also follow these steps to find out how much excess reactant remains. So going back to this view, big minus little, convert to excess. So big, that's this value. Little, right here. So big minus little, that will be 0.0270 mole KCl minus 0.0241 mole KCl. 0.0270, just using the calculator. 0.00290 mole KCl. So this is how much could have been produced, but we don't want to know excess product. We want excess reactant. So then we need to go back to our excess reactant and convert from moles of KCl to moles of our excess reactant. The excess reactant in this case is anything that's not the limiting reactant. So in A, we found the limiting reactant. The other substance, that's going to be our excess reactants. So that will be KBr. Mole over mole, use the coefficients. So that will give us 0.00290 mole KBr. This is our excess remains. This is how many moles of excess remains. Now, if it asks you to go to grams of KBr, you would just add, that one more step, converting from moles to grams. Okay, Cubs, I'll post another practice problem video. Let me know if you have any questions, and have a great day.